Hi everyone. In this video, I want to go over a couple of examples of estimating the population mean. So we talked about it, just to refresh your memories, we said if, well, population means x bar minus c mu and x bar plus c, that's the confidence interval, and e is the margin of error. And there are two cases. You can use z, the normal distribution, or you can use T, the student T distribution. We use Z when sigma is known, or sometimes when n is greater than or equal to 30. When n is greater than or equal to 30, those two distributions have very uh, similar numbers that are critical values that are very close to each other. So an E equals to T sub alpha over 2 times S over square root of n. We use this if sigma is unknown, that means we can calculate S, the sample standard deviation, or n is less than 30. But just know sigma known, use normal distribution or z values. Sigma unknown, use the t distribution or t critical values. So we went over on how to read the table. So here I prepared a couple of examples for you to see how that works. For example, we have test scores and we have a sample, and these are the test scores: 70, 89, 91, 43, 35, 99, 85. This is our sample. N is 7 because we have 7 numbers in our sample. It says with 95% confidence level, estimate mu, the population mean. First thing to notice, this is a sample and sigma is not given. And the problem is going to mention if sigma is given or not. So what we need to do here, first find the sample mean and find the sample standard deviation, which is S. These are the formulas for sample mean and for sample standard deviation. You can use the formulas, or you can go to your calculator and put X's. X's here are the test scores in L1, and just do 1 var stats. If you do that, you get S is 25, or S sub X, calculator writes S sub X. And the mean is 73.14. So obviously here we have S, so we're going to use T. And your calculator, do not use sigma sub X, because we're dealing with sample standard deviation. So this is the confidence interval. X bar, we already found that by using our calculator, is 73.14 minus E, and X bar plus E. The formula for E, since we have S, we're going to use T, is X bar minus T sub alpha over 2 times S over square root of n, and we have less than mu and less than X bar plus T sub alpha over 2 times S over square root of n. Now what we need to do is find this critical value. I showed how to use the table, but you can use your calculator. It's 90% confidence level, so this is 90. We need to know the area in the tail in order to use our calculator. So it's 1 minus 0.9 divided by 2, and that's 0.05. So in your calculator, you're going to do inverse T, 0.05, and 6. 6 are the degrees of freedom. So which is 7 minus 1, and minus 1 is 6. So if you do that, you get negative 1.943. However, for calculations, as I said, we always use the positive one. So it's 1.943 times S We got it here from the calculator, divided by square root of 7, and 7 is n, the sample size. If you do that, you get 8.36. Writing the interval again, so it's x bar minus e, which is 73.14 minus 18.36, and less than mu, and that's less than 73.14 plus 18.36. So you get 54.78 less than mu and less than 91.5. How can we say that? We say if the sample mean is 73.14, then we are 90% confident because the confidence level is 90%. We are 90% confident that the population mean will be a number between 54.78 and 91.5, which is the confidence interval. And I put the steps for you. The first step for the same problem, what you need to do is find x bar and s using the calculator. One more stats. Find t sub alpha over 2. You can use the table or calculator, knowing the degrees of freedom is n minus 1. So you do inverse t area and degrees of freedom. Then calculate the error, and once you have e, write the interval. So that's what we did. I put another example here for you. I let you try, follow these steps, and then you can check the solution. So same way. And I put all the steps here for you too. Now, another way of doing this, you can do that by using your calculator. So just get the interval. And to do that, you go to stats. So push stats and go to the right. It says tests. Take tests and scroll down to number 8. It says T interval. When you go to T interval, for input, you see data or you see stats. Pick stats, highlight stats, and then put those numbers. They're going to ask you for the mean, for standard deviation, and the confidence level. So if you put that, then the calculator is going to give you this answer directly. Or you can, for input, you can use data, and since you have all these numbers in L1, when you put the data, it's going to ask for which list and just put L1, and then just say put the confidence level and calculate. So the calculator will give you the answer, the same answer. Another example, x bar is 20, n is 35, and the population standard deviation is 5. I said population standard deviation. So in this example, that means here sigma is given. And I wrote it, x bar is 20, n is 35, and sigma is 5. Confidence level 90%. We use z because sigma is known. So here the margin of error is going to be z sub alpha over 2 times sigma over square root of n. So in order to find z sub alpha over 2, we do inverse norm. We know 90% is right here. Same thing, we have to find the area in the tail. 1 minus 0.9 divided by 2 is 0.05. And you get, this is 90%. And as I told you, for this one, we use negative 1.645. All the calculator is going to give you negative 1.644. So then we can calculate the margin of error. Z, we have it. Sigma is 5, given in the problem, over square root of n, and n was 35. You get 1.39. X bar is 20 minus 1.39, and on the right side you have 20 plus 1.39, and that's our confidence interval. If you want to use your calculator directly, go to Z, go to, again, stat, highlight test, and then number 7 is Z interval. So then just input the numbers, and the calculator is going to give you this number. Next thing I want to talk about is the sample size. The margin of error is this formula, E equals to Z sub alpha over 2 times sigma over n. Sample size is to find the sample size. So what we can do is square both sides, use some algebra, and when we square both sides, we get rid of this square root, and you can cross multiply, and you get n equals to Z sub alpha over 2 squared times sigma squared over E squared. So now I put an example here for you. Confidence level is 99%, E is given to be 5, and sigma is 10. Find n. All you have to do here, find the critical value for Z. Same way, this is 99%. This area is 1 minus 0.99 divided by 2, which is 0.005. So you can do inverse norm 0.00501, and you get 2.58, but that's the special one too. We use 2.575 times sigma is given in the problem. 10 squared divided by E is given to 5 squared. If you do that, you get 26.52. You can't use this number because sample size cannot be a decimal. And as I mentioned before, you take the next whole number. So in this case, n is 27. Don't forget to round up for the sample size. Even if the number is 26.001, you have to take 27, which is the next whole number. So you can use these examples and start the homework for estimation. Now you can do estimating population proportion, population mean, and population standard deviation. Everything is ready for that. Hope you have a good one, and I'll see you soon. Bye-bye.